so there wasn't a hole. For the vertical asymptotes, there were two, because there were two factors in the denominator. There is a horizontal asymptote, but since the degrees were the same, we looked at the leading coefficients. And then we had two x-intercepts from our numerator. One of them happened to also be the y-intercept. Excellent. Let's sketch these in, graph these vertical asymptotes, and please get as close to being accurate as possible. I know 1/2 is a little bit challenging. Do the best that you can, please. Alrighty, so we need to see where our y values fall. Let's go ahead and make our number line. Remember, this is a representation of our x-axis. What two characteristics go on this number line? Who remembers from the last example? Andrea?
The vertical asymptotes and x.
Beautiful. Yep, those are the only two. If you need to write that down, those are the only two. So the first thing we come across is a vertical asymptote at -1/2, and then an x-intercept at 0, another x-intercept at 1, and then another vertical asymptote at 3. If you need to, sketch in what each of these represents so that you can connect them a little bit easier with the graph. Not necessary, just a suggestion. And let's test. What is a number less than -1/2 that we can substitute in for x? -1. Yeah. Okay, so for that first region, I'm going to use -1. And here's a perfect example of the choice between the factored form or the standard given form. I'm going to use the factored form, and here's why. If I take 3 times -1 times -1 minus 1 over -1 minus 3, and then we have 2 times -1 plus 1. Oh my gosh, the surface is lagging. Here's why I prefer the factored form. 3 times -1. Is that a positive or a negative number? It's going to be a negative. What is -1 minus 1? Is that a positive or a negative number? It's going to be a negative. So in the numerator, we have a negative times a negative number. Now in the denominator, what is -1 minus 3? Is that positive or negative? Negative. And then 2 times -1 plus 1, is that a positive or a negative number? Negative. The reason I like the factored form is it allows me to sort of, pardon me, deal less with the numerical value and more with the signs. In the numerator, what's a negative times a negative? So we have a positive divided by a positive, which is, hey. So in that first section, that first region, our graph is going to be above the x-axis. Go ahead and fill in the rest of the regions. I'll do so as well. We can match our answers. Pick values in between and see how you do. We know that we have to start at the horizontal asymptote, right? So, since we are, why is this not moving? There we go. Since we're above the x-axis, we could start above the horizontal asymptote, curve to the right, and then curve up because we can't cross the vertical asymptote. But we can cross a horizontal asymptote. So you also could start below the horizontal asymptote as long as you're not crossing the x-axis, extend towards the right, and then end up curving up towards the vertical asymptote as well. Either sketch is acceptable because you're adhering to the end behavior of the horizontal asymptote and not crossing the vertical. For me, I'm going to stay above, and then I'll curve up by the vertical asymptote. Now the next region, we are below the x-axis. This one's a little bit tight as far as space is concerned, so I'm going to start by the vertical asymptote. Maybe. There we go. I'm going to go up, and I'm going to have to include, I'm going to have to touch the x and y intercept. From here, my number line tells me to go up, and then I'm going to have to curve back down because I have to include the x-intercept. Okay, I had to curve back down because I had to include the x-intercept. Where do I go in this next region? Do I bounce back up or do I go below? Below. We go below. So we're going to have to go below the x-axis, ending by our vertical asymptote. For the very last region, where are we supposed to go? Are we supposed to be above or below the x-axis? Above, because our y values are positive. So we're going to have to start at the vertical asymptote and then go down, ending at the horizontal asymptote because that is its purpose. Now here, again, you have a choice to make. Can I cross a horizontal asymptote?
Yes.
Yeah, its purpose is to guide the end behavior. So maybe you want to go down and you want to cross the horizontal asymptote. That's fine as long as you end there and you don't cross the x-axis. Why can I not cross the x-axis here? Jen? Because it would go negative. Good. And what else? What do we not have? Yeah. Yeah, we would have to have another x-intercept. So all of these little nuances we have to keep in mind. For the purpose of my graph, I'm going to stay above, and so then I curve to the right. What is restricting the domain here? Anything? Do we have any restrictions on the domain at all? Yes or no? Chloe? Yeah, thank you. The vertical asymptotes, everyone, is always going to restrict the domain. So if you want to write that down, please do so. Our domain is going to be all real numbers except x cannot equal -1/2 or 3. For interval notation, we're going to say that it goes from -∞ to -1/2, non-inclusive union, -1/2 to 3, both non-inclusive, union 3 to infinity. Now, as far as the range is concerned, here's a perfect example of how it's going to differ based off of how you graphed. For me, this middle part goes down to -∞, right? So I'm going to start at -∞, and I'm going to go up. And it looks like my curve goes about to 0.75. Okay, I'm approximating. Then I have some space where my function doesn't exist because I did not cross the horizontal asymptotes. I stayed above. So I did get really close to them. I'm going to say that I go from -∞ to 0.75, and then I start at 1.5 to infinity. Your range has to match your graph. If you cross the horizontal asymptotes, your range might be a little different than mine, and that's okay. What I'm going to look for on a test or a quiz or your homework is that even if your sketch is wrong, does your range match your graph? That's what matters to me. Yes? Okay. So, for my range, I'm going to put